Okay, so somebody's asked me about quadratic equations and how do you set up an equation, a quadratic equation, and to solve a quadratic equation. So in the book, it says, when an object is launched or thrown from some height, h sub 0, in feet, with an initial upward velocity v sub 0 in feet per second, the height in feet of that object t seconds later is given by the function h of t equals negative 16 t squared plus v sub 0 t plus h sub 0 sub 0. And this is really a really standard object thrown or launched equation. This one's specifically dealing with feet, and there's one that's very, very similar dealing with meters. And so we can use this to talk about the motion of an awful lot of objects if given 2 bits of information. And the 2 bits of information that we need are some height, so this gives us initial height is going to be our h sub o, and initial velocity is this v sub o. Okay, and so once we're given that information, then we can figure out what it is. So let's look at our example. Suppose you're standing on a deck so that your hand's 7 feet above the ground, and you gently toss a ball straight upwards at 5 feet per second off the side of the deck. So in there, we're given 2 bits of information. We're given this 7 feet, and we're given this 5 feet per second. So remember, our equation is missing h sub o, which is initial height, and v sub o, which is our initial velocity. So looking at this, is our 7 feet that we start out at, is that going to be our initial height or initial velocity? Right, that's our initial height. So that's going to be 7. And so our 7 feet, or sorry, our 5 feet per second is going to be this initial velocity. And so this part A that says state the equation that models the situation, don't make this harder than it is. It really is just plug in the little bits of information that we know. So our equation that models, we said, is negative 16t squared, plus we said that the v sub o is 5t, and that our h sub o is 7. And that's all it's looking for A. Just plug in those 2 values to get how this particular object is traveling. So that's really kind of straightforward. Okay, so part B says, let's set this equal to 0 and explain what it means in the context of the problem. Okay, so I want to take the h of t and set h of t and set it equal to 0. Well, h of t is this entire thing, right? Okay, so we're going to be, kind of looking at this part of it. Okay, so we have to solve this. And for linear, we would say, get the variable by itself. But because we have this t value, this squared value right here, it's t squared, that throws a lot of stuff off. And we cannot just isolate t. And so it turns out that there are actually lots of different ways of solving this. The way we're going to use is we're going to do quadratic formula. And quadratic formula says if you have 0 equals ax squared plus bx plus c, then x is negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so notice that our equations have t in it, and this has x's in it. That's okay. We just have different variables. It's perfectly fine. But we do have to decide what is a, what is b, and what is c. So for this case, for all cases, A is the number in front of the squared term, the squared variable, not including the squared variable. Okay, B is number in front of the variable without the square. Again, not including the variable. And C, I'll put C over here, I guess. C is the number by itself. Okay, so for our problem, we're going to have to look at this, and we're saying, okay, well, what's my number in front of the variable squared, the squared variable, the t squared? That would be a negative 16. For us, A, I don't know, I have the negative there. A is negative 16, negative. And B is the number in front of the variable. So what's the number in front of this variable? In this case, B is 5. And C is the number by itself. The number by itself is 7. So we're going to do negative 16 for A, 5 for B, and C is 7. So next thing's next. Let's plug that into our quadratic formula. So we've got negative 5 plus or minus square root of 5 squared minus 4 times a negative 16 times 7 all over 2 times a negative 16. Okay, next fun part comes is how can we simplify this down? So if you've got one of those multi-step calculators, you can take this entire thing here, called the discriminant, and let's do this in green. If two-line calculator, throw that entire thing under the square root into your calculator. Put expression. Calc. Okay, so you would literally put, 5 squared minus 4, use your parentheses, negative 16, 7. You'd throw that into your calculator and you should get 473. Okay, if you don't want to do that, or you don't feel comfortable doing that, or your calculator is not a two-line calculator, so you're going to have to do it more in steps. So if a one-line calculator, we're going to have to do this in steps. So first, square the b. So for us, now the next line is going to be negative 5 plus or minus square root 25 minus 4 minus 16 times 7. And you can go ahead and do this calculation on the bottom. Okay, so here's the next part, which is kind of tricky. After the squared b, for the next three numbers, count the number of negative signs. So count number of negative / subtraction signs in the next three numbers. So for us, well, this number has a negative, that number has a negative, but 7 does not have a negative. So I have two negative signs, and the deal is if it's even, put plus. If it's odd, put subtraction. then multiply the three numbers, ignoring all signs. Ignoring all signs. So for us, our next line would look like -5 plus or minus square root 25, because we have 2 negative signs and 2 is even. A negative times a negative gets me a positive. And then I do 4 times 16 times 7, which should be 448 over my -32. Okay. Now we're going to go ahead and do that calculation under the square root. Complete calculation under your square root. So for us, that would now look like -5 plus or minus square root. And notice we should get this same thing as our two-line calculator should be. Okay, so now, calculators are going to be the same. Okay, now go ahead and find the square root. Probably is going to be some big decimal. Rarely it's not going to be. This one ends up being 21.748. Oh, let's round that to 6. And still over -32. And now we're going to talk about this symbol right here. And what does this symbol actually mean? This means that it's sneakily 2 equations in one. And so at this point, I suggest we break this into the 2 equations that it represents. So one of the equations is -5 plus 21.7486 over a -32. And the other one's going to be a -5 minus 21.7486 over a -32. Okay. Now let's go ahead and simplify it. So calculate the tops of both of those. A -5 plus 21, positive 21, becomes a positive 16.787486 divided by a -32. And when you divide that out, you get a -5234. And over here, we've got a -26.7486 over a -32. And if you divide that out, then you get a .8359. Okay, so we've calculated it. We've gotten 2 answers. And but once again, the difference between this class and an algebra class is you have to understand the context. And so what do these 2 numbers mean, And so if we go back up, let's go back and we said, okay, we set my h of t, and h of t represents the height being equal to 0. We set the height equal to 0. And we found, even though this says x over here, we weren't using x. What were we using? We were using t. So we have a t equals these 2 things. Well, what does t represent? T represents time. So this is a t equals and a t equals, and t is time, the time it takes. So does it make sense to have a negative time? No, that would be talking about before we actually threw the ball, and that doesn't make a whole lot of sense. Let me see, that's nope. Does it make sense to have a positive time? Well, yeah. And so this would be a 0.8359 seconds. So the question now becomes, does this answer make sense? So it takes less than a second to hit the ground. Well, let's take a look at where what the problem actually is. We said we were only 7 feet above the ground, and I gently tossed the ball up at 5 feet per second. And so the ball was tossed really really gently. So it probably barely made it out of my hand before coming down. And so if you're 7 feet in the air and you toss it up only a little bit and then let it come down, does it make sense that it took less than a second to hit the ground? Yeah, that seems pretty reasonable to me. And so that's a pretty good answer. So if I wanted to write this in a sentence, it would say, after 0.8 seconds, the ball hits the ground. Hopefully that helps. Let me know. And if you have other questions, I'll work on those too.